Now we're going to talk about contact angle. Contact angle is a quantitative measure of the wetting of a solid by a liquid. So let's talk about what that means in a practical sense. So there's a lot of math behind this, and we have there's a well-known equation called the Young equation. We're not really going to go into that. We're just going to do some of the basic stuff. So what happens when I introduce a liquid against a solid, and I drop a liquid on there? One of two things is going to happen. One, the liquid's going to bead up, or two, the liquid's going to kind of flatten out. Now, if any of you have ever waxed your car, you're probably familiar with this. A well-waxed car will end up looking kind of like this. It will bead up. A not well-waxed car will end up like this, where the water will hit and flatten out. So what's going on is on the well-waxed car, the surface is basically hydrophobic, which means that the fluid wants to touch as little of the material as possible. On a not waxed car, the surface becomes more hydrophilic, which means the fluid wants to touch everything that it can. And so what we have is it's all going to be based off of what this angle is with the fluid. So let me change the color here. Go red. And so as you measure that angle, you've got one of two things going on. You've got an angle here, that angle theta, and this angle is greater than 90 degrees. And then we have this angle here, it's also theta. That theta is less than 90 degrees. So now what is going on is this is the concept of wetting. So wetting just really talks about how much fluid touches a surface. So in the case where the contact angle is less than 90 degrees, we say that the fluid wets the surface. And it just means that we're getting as much contact as we can. And over here, with it's balling up, it is not wetting the surface as much. And so this is what contact angle is talking about, is how much of the surface it's interacting with. Now, this one's interesting because much like surface tension, because you do have a surface here that is caused by the surface tension, let's say it's water, in this case it would be between the water and the air, which is what's causing the bubble. But it's not just that interaction you've got to worry about. You've also got the solid surface that it's interacting with. So that means as we sit here, because we can look up contact angles because they're a tabulated thing, but because of that we need three distinct properties to look up. So a very common one when we're looking at things would be, what's the relationship between mercury, air, and glass? Because this is used in a lot of scientific instruments. So you would look that up, and it would tell you that, oh, the contact angle for that is 130 degrees, which would be in this, over here, in this more non-wetting situation. Another common one that we can look at is water, air, and glass. And this has a nominal contact angle of 0 degrees. Now these are all approximate, but this is what causes those meniscus in your experiments that you did in chemistry. In fact, if we take a look at this next slide here, so we can look at a wetting and a non-wetting surface. Now, one thing that I do want you to note, and this is very important because in the last part I was talking about drops on a flat plate, and now we're looking at fluid in a tube. The way the angles are measured are a little bit different. And so the angles, when you're measuring in the tube, are kind of flipped, because if we go back here in the last one where I'm showing you with the droplets, we measure the droplet on a flat surface. That theta is greater than 90 degrees. It's non-wetting. This one's less than 90 degrees. It's wetting. Well, when we're dealing in a capillary tube, as you can see how they're measured here, that is more, now that my angle is less than 90 degrees, it's wetting, because that's what's causing the depression, because all of this fluid here is it's being hydrophilic. It's trying to touch as much as everything it can, in the case of water. And then over here, we've got the depression, you notice that the fluid's popping up in the middle because over here it's trying to touch as least amount of material it can on the sides because now the surfaces are hydrophobic. So it's always really important to know what you're looking at angle-wise and what you're trying to calculate out. So why does this depression happen? Well, this really comes down to you have to balance out the weight of the column and the surface tension forces. So one of the problems that you could be asked would be, okay, well, how much is that depression? See, both of these pictures have that dimension h. Well, how would you calculate that out? Well, you could do it by saying, okay, what's the weight in the column? Weight of the column, because we have all that fluid there. Well, that has to equal the pressure force due to surface tension. To surface tension. Okay, and so in that case, well, how do we figure out the weight of the column? Well, the weight of the column of the water is going to be, we take the specific weight, so that's density times gravity, and then we multiply it by the volume of our column, pi r squared, our radius, times the height of the column. Well, and then we have to calculate the surface tension forces. Well, how do we do that? Well, we take the circumference of the circle, 2 pi r, and then we multiply that by whatever our angle is to figure out what the projection of that angle is. So cosine theta, and let's clean that up real quick, cosine theta, and then we multiply it by the surface tension force because that will give us a linear measurement, and now we need to know what is the force per linear measurement. That's our surface tension force. And so you can quickly calculate out that go, okay, well, the h value is going to be twice the surface tension force cosine theta, and then we're going to divide that by gamma r. And so that would be the equation to calculate out the contact angle. We're not going to do much with contact angle in this class. We may ask you how to calculate out h, but that's not one of the more important things that I'd like to focus on.